Dr. S.K. Goel. Dr. S.K. Goel is working as assistant professor in the Institute of Agriculture Sciences at Banaras Hindu University, Varanasi. Dr. Goel is a BTech from CSA University of Agriculture and Technology, Kanpur, and MTech from Indira Gandhi Agriculture University, Raipur, and completed PhD in Agricultural Process and Food Engineering from STP University of Agriculture and Technology, Meerut. Dr. Goel is a recipient of 2 national awards and more than 15 international awards. He organized many international and national seminars, conference, workshops, etc., and other scientific events, and has so far published 22 books, 19 chapters, 61 papers in various journals of international and national repute. He handled many research projects funded by various agencies such as BSc, UGC, Ministry of Agriculture and Farmer Welfare, BHU, etc. Presently, Dr. Goel is engaged in teaching research and extension and also guiding PhD and MSc students. Dr. Goel also holds an expertise as drone pilot. So with this brief introduction, I request Dr. Goel to start with his talk. Dr. Goel.
Thank you, Dr.
To the forum.
Thank you, Dr. Manika.
Thank you, sir.
Welcome to this 1-month international training program conducted by AgriMeet Foundation. And I am thankful to Dr. Ankur Sharma and his vast team who is conducting this very important topic, choosing this important topic for this training program. So, Namaskar. I am Dr. Sunil Kumar Goyal, working as assistant professor, as Dr. Manika told about me. So today, the topic of my talk is precision irrigation. 1 minute.
Can we have this full screen?
Yeah. Now it's in full screen, ma'am, or not?
Yes, sir. हो गया. Full screen पे है. जी, sir.
Thank you, sir. Thank you.
Okay. Thank you for cooperation. So in this precision irrigation, I will be covering about general issues of water, population, and agriculture with irrigation. Facts about water. Then what is irrigation? We all know because we all are related to agriculture. So we all know what is the irrigation. Still, I am going to discuss a little bit about the irrigation and scientific definition of irrigation and other things. Then in my next step, I will be covering precision irrigation, and in my presentation, in my many slides, this will be as indicated as PI. Next slide will be irrigation and fertigation, and at the last, as you know, each talk or each lecture has few messages, or you can say conclusion, that is known as take-home message. So with these salient points, I am directly come to the point. Friends, irrigation is related to water, and we all know water is very precious gift giving to us by Almighty or God. So there is a quote that is given by UN Committee of Economics, Cultural and Social Rights. Water is a fundamental for life and health. The human right to water is indispensable for leading a healthy life in human dignity. It is a prerequisite to the realization of all other human rights. So if there is no water, then we can say there will be no life on the earth, as well as the plants or other entity, or you can say other organisms, other living entities needs the water for their survival, to complete their life cycle or to complete their day-to-day activities. Then if the water is very important, then importance felt by the UN committee, and the period of 2005 to 15 was the international decade for action water for life. So you can easily imagine how the water is important for this universe, you can say, or especially for this earth. Actually, we are using this water, and we are wasting much more water what the quantity as we required. So that's why there is a water scarcity globally. We are facing this problem. Okay, so the criteria of this water scarcity is if the availability of water is less than 1000 meter cube per capita per year, then it will comes under this severely water scarce. That region is known as severely water scarce region. And if 1000 to 1700 metric cubic meter per capita per year availability of the water, then that region is known as water scarce. So these are 2 points. By using these points, we can say this area is scarce of water, and this area is severe water. This area affecting with the severity of water scarcity. Okay. Now the status. What was the status in 90s? When we are seeing this global scenario, then we found near about 18 severely water scarce countries were found in during 90s. In these countries, near about 500 or less than 500 cubic meter water availability per capita per year found. Okay, and if we think about future, then we found approximate 30 severely water scarce country may be available if the water, we are using this water judiciously. Okay. So these data is from FAO water budget. Then question arise, do we have enough water? Because when we talking about water, when we talking about water within the educated pupils, then we can think, yes, we don't have enough water. And if we are talking this fact with illiterate populations of the birds, then they simply said, you can say the layman simply said, there are ample of water. There are availability of water is abundant. And many pupils can say there are seas available in the universe. So there are different types of sea available, and there is ample of water. But the situation is not like that. With 2085 cubic kilometers of fresh water, India stands 7th in the world. And India heading towards water scarce situation still. If we are looking behind with this data, during the independence era in 1947, per capita availability of water was near about 6,000 cubic meter per capita per year. Then during 1994, it reduces and it became near about 2,200 cubic meter. And today we are living in 2023. This data is projected data, and this is these data is taken from Biswas AK 1998. Though the reference may be older, but that is the expected data. So we can say during 2025, this availability of water of Indian scenario may definitely be reduced, and it will be about 1500 cubic meter. And if we talking about 2050, then definitely it will be reducing, and the data may be near about 1300 cubic meter per capita per year. So with these data, you can easily understand the availability of per capita availability of water in our country as well as a globe whole. Availability is day by day, or you can say every fraction of second, this availability is decreasing day by day. So we don't have enough water. Okay, now your picture may be clear. We don't have enough water. There is a small, excuse me. Okay. There is a few facts that I don't know, might heard about this or not. This picture shows that virtual water for some important products. Okay. What is the virtual water? Virtual water is the volume of water required to produce a commodity or service. And this definition is given by Tony Allen during 1990. Okay. So if we are taking a cup of coffee, it means 140 liter water has been utilized for the production of 1 cup of coffee. Likewise, if we are using 1 kg of maize, it means 900 liters water has been utilized for the production of this 1 kg of maize. The same is happening for the rice. Okay. If we are you produced 1 kg of rice, it means 3000 liter water is utilized for the cultivation of this rice production. Okay. And most important, if we are using 1 kg of wheat, it means it consumes 16,000 liter of water for the production of this 1 kg of wheat. So with this picture, there are two simple messages. First one is, we should be as a vegetarian, because with this slide you can easily understand, if we are using maize and if we are using rice, and generally these are using by the vegetarian pupils, then we are using very less amount of water. And if we are using 1 kg of beef, it means it is consume a huge amount of water. You can easily understand 16,000 liter water for 1 kg of beef only. Okay, so it is a very difficult situation for understanding for ourselves only. Okay, so by importing virtual water, poor countries can relieve the pressure on their domestic water pressures. Okay, so it is a clear picture here. Then next, water valuing. This is a similar thing, but it will giving different task. Okay, what is the water valuing of water? It means paddy requires approximate 120 centimeter of water for survival, or you can say production, successfully cultivation of a hectare of land. Okay, if water is priced at 1 paisa a liter, then it costs near about 1,20,000 for growing paddy in 1 hectare land. This is known as valuing of water. So this is only for paddy. You can calculate this for wheat, for other crops. That will be very beneficial for our country, or as well as our farmers and other policy holders. What we are doing, now you can easily understand that how water is very important for us, for agriculture, for human being, for animals, and whatever available on this earth, they all generally needs the water. Still we are wasting our water in the fields, in the form of irrigation. What we are generally doing? Generally we are irrigating our fields like this. Okay, it means we are wasteful resource irrigation. These all are wasteful resource surface irrigation method. Okay, that's why today I have chosen this talk regarding precision irrigation, because precision irrigation is directly related to precision farming or precision agriculture, or you can say precision irrigation is a part of precision agriculture. Okay, if we are using such type of irrigation methods, then what is happening in our country, in our village, in our nearby places, and around the world? What is happening? The groundwater level is continuously depleting. Generally, people are saying, "Saab, pani niche chala gaya." What is the mean? Pani niche chala gaya. Pani niche chala gaya means the groundwater is continuously depleting because we are harness very roughly. This is a very important natural resource. Okay? And what other things we are doing? Water diversion for domestic demands. So there are two main things for which this water is utilized. The first one is agriculture, second one is domestic demand, and third one and four most important thing is industrial demand. Okay? But here I am just talking about agriculture. Okay. Now, what is the global water availability? Near about 97.3% is salt water. What water is available on the earth? From that, 97.3% is near about salt water, and only 2.7% is fresh water. Fresh water means that water we can use for irrigation purpose, that water we can use for industrial purpose, that water we can use for our consumption, for drinking and other things. That means we can use this water as a domestic utilization. Okay? And now only this 2.7 fresh water is available on this earth in different ways. You can easily understand with this pie chart. This 68.8% water is available on this earth as a glaciers and snow covers. We know the top hills and glaciers. If we are talking about in Indian context, then Himalayan regions, Himalayan glaciers, Leh Ladakh, okay? And top hills, those are covered with the snow. So this 68.8% water is available like this, glaciers and snow cover. Freshwater lakes, only 0.3% water is available in lakes. And fresh groundwater, near about 30%. It means 29.9% water. This fresh water, 29.9% is available in ground, and only 0.9% this fresh 0.9% of this 2.7% water is available in our soil moisture. So this is the bifurcation of fresh water, or what is the water available on this earth. So this is the total breakup of that water. Okay. Now, if we are talking about resources and abilities of our country, sorry, then fresh water resources we have, means our India have fresh water resources of 4% of globally available water. It means our country has only 4% of global water available on this earth. Then, excuse me. And if we're talking about land, then we have 2.4% of global land. And if we are talking about population, no doubt we are topmost in the category of population. We are number one in the world. Now we are 1.4 billion population. We have 1.4 billion population. Still, that is only 16% of the bird population. And if we are talking about rainfall, then we have 1180 millimeter. That is average rainfall. That is average rainfall of globally, if we are counting. Now, population per capita and per capita availability of water availability. You can simply see in this slide, as the population is progressive, then water availability is naturally declining. It means when the mouth, if the mouth and population or hands will increase, then definitely the water availability will definitely decrease. In this picture, you can easily understand India per capita water availability. There are two lines. Kindly see carefully. The middle one is water scarcity line. This brown line is known as water scarcity line, and this yellow one is water stress line. So during 2001, or you can say before 2001, or we can say up to 2001, our country, or we are near about water stress line, means we have, at that time we have just only 1800 cubic meter per year per capita water availability. But as we progress from 2001 to 11, then 11 to 25, and 25 to 50, then what we can see in this with this slide, the per capita availability is decreasing day by day, and our country, means we are living in water stress line, under water stress line, and after some time, beyond 2050, definitely our country will also be under line of water scarcity. So there is a time, we have time, we can do something. So we could not go beyond this water scarcity line. Okay. Now, again, you can see a simple picture, as earlier I have shown you. Generally, what we are doing in agriculture field, we are using wrong practices. We are using wrong irrigation methods. If we are using wrong irrigation method, then what happens? Wrong irrigation practices decreases the cost, decreases the crop yield, and increases the energy and cost. So this is directly proportional to each other. If we are using wrong practice, then it means it decrease the crop yield and increase the simple, you can say, increase the production cost. Okay. So what we are doing, generally we are doing flood irrigation. These two pictures are showing the flood irrigation method. As the farmers are using this canal system, then generally they are using this system. And if you interrupt them, then what they said, I paid the money for this irrigation water, but they don't know they are paying the water for this. They are paying for this water, but this water is not only for belongs to them. This is the, you can say, national resource, national treasure. So we have to think about to reduce the wastage of this water in the agriculture field, so that we have to use different types of irrigation methods. Those are use this water judiciously, and there are a saying, you are saying, more crop per drop. Okay, many of you have listened or read and write many times, many places, your exams, your different types of activities. Then there are these lines, tag lines, you can use in your hoardings or banners. Okay. And the next situation is farmers they are using their tube bells. They pulled this groundwater with the different types of means, tube bells, submersibles, and other types of motors, pumps, and then they are using, you can say, some losses are you can say minimized in this method. Okay? But almost all methods are very wrong. So what happens, effects of, if we are using improper or misuse, then what happens to our agriculture or our Indian land or Indian context we are talking about? Then if we are using this type of wrongly methods to irrigate our crops, then there are waterlogging. Near about 8.4 million hectare area is waterlogged in our country. There are many areas, those are affected with this soil salinization. Yeah. Health hazard is also privileged in that areas. Okay. The reduction in agricultural productivity, definitely when you applied more water to your crop or your plant or your field, then definitely the plants cannot develop in their good condition, and then the crop yield definitely will be declining. And the most important, high energy cost. High energy cost means if you are using electricity to operate these pumps, motors, then it increase the your irrigation cost. If you are using any type of fuel, means petrol, diesel, or solar, so it means whatever you are using to acquire these different types of water, that may be underground, or you are paying for the canal employee, it means it enhances the production cost. So there are two things. First one is your input cost is enhancing and your production definitely will be reducing. So there are different, totally the losses goes to the farmer's pocket. Even after exploitation of all available water resources, only 40 to 50% of agricultural will still remain and rain-fed with current efficiency of irrigation. It means if we are regularly and continuously using irrigation methods, those are available present time, or we are using from our you can say older time, then near about 40 to 50% of agricultural land will be remain this rain-fed. Rain-fed means Barani. Okay. World Water Council in the year of 2000, they give some words regarding this water. There is a water crisis today, but the crisis is not about having too little water to satisfy our needs. It is a crisis of managing water so badly that billions of people and the environment suffer badly. So it means we are not managing our available water with a good tactics. Now, irrigation. Actually, you all are, I think you all are from agricultural background, so you all are very well knowing the irrigation, but still there is a irrigation given definition of irrigation given by Dr. A.M. Michael, who is a renowned scientist of irrigation engineering of our agricultural engineering field. It is defined as the science of artificial application of water to the land in accordance with crop requirement throughout the crop period for full-fledged nourishment of the crops. So this is irrigation. And what our farmers are doing, they don't know about these facts. Generally, they are flooded their fields with the water, and then they think now my field is irrigated. So this is really irrigation, and that is not irrigation what our farmers are doing. So there is a need to teach the farmers with the right manner. If we are generally we all are agriculturists, and we are not able to teach our farmers regarding the irrigation, then what is the meaning of our education and degrees? Okay. Now, irrigation definition, there is another definition of irrigation. Irrigation is defined as the process of artificial application of water to the soil for the growth of agricultural crops. This is a little bit simple. Okay. You might be you can say surprised. There is a branch of engineering that is known as irrigation engineering. Okay. In our Indian universities, especially agricultural universities, universities have irrigation engineering department, and in the IITs, means civil engineering departments, they also have irrigation engineering departments, or you can say sub departments of irrigation engineering. Okay, so it is the, what is the irrigation engineering? It is a science dealing with planning, designing, construction, operation, and maintenance of various irrigation works. So what irrigation engineer did? That irrigation engineer did planning, designing, construction, operation, and maintenance of various irrigation works. Now, the question arises, necessity of irrigation. I am not telling you the rocket science. I am just reviving the things, whatever you know, because I am talking about precision irrigation. So you have to clear all the facts, all the small things. Sorry, those are related to irrigation. That's why I am talking about all the related to irrigation. So necessity of irrigation. There are basically two things. Those are related to directly of the necessity of this irrigation. First one is insufficient rainfall. As we know, total rainfall is less than needed for the crop. Artificial supply is necessary. We all know, for example, if we have a crop of 90 days, then if the crop required 4 irrigation at a particular time, or you can say specific time interval, then do you think the rainfall would be at that specific time, means 4 times for that particular crop? So this is the main reason, insufficient rainfall. Second one is non-uniform rainfall. Means rainfall in a particular area may not be uniform over the crop period. Okay, this is clear. The next one is growing a number of crops during a year. That's why we need irrigation. Growing perennial crops. That's why we need irrigation. Commercial crops with additional water. That's why we need irrigation. And last one, last but not least, controlled water supply. Apart from these points, there are number of points, number of you can say causes. That's why the necessity of irrigation for this agriculture field. Now the question raises types of irrigation. At present, I am talking about only, you can say, older irrigation practices. You can say traditional irrigation practices. Okay. Now, you can easily understand with this picture. There are 2 types of irrigation: surface irrigation, subsurface irrigation. Surface irrigation means the water giving to the field, to the plant, upper surface of the soil. And subsurface, it means the water is supplied beneath the surface. Okay. Then this is divided into two times: flow and lift. And this flow is divided into flood and perennial. Then subsurface is natural subsurface and artificial subsurface. So this is the total irrigation methods, or you can say irrigation types. Those are used in our Indian agriculture, or you can say the globally agricultural system. Generally, these types of irrigation system were used. Now, if we are using all these types of irrigation system, this is exceptional case, subsurface. If we are using surface irrigation system, then what happens? Then this decrease efficiency in conventional irrigation. If we are applying this surface irrigation method, then what happens? Water is evaporated with evaporation process. It goes out with wind drift, then transpiration from vegetation, then infiltration in the soil, then deep percolation in the soil, then evaporation from soil surface itself, and runoff. But means your irrigated water can be move outside from your field. So due to these all reasons, the traditional irrigation methods are not suitable for our agricultural system. Now precision irrigation. Now the precision irrigation is come to the picture. Okay, so this precision irrigation is also called site-specific irrigation. I will let you later why this is called site-specific irrigation. PI is a tool of precision agriculture that involves the delivery of irrigation water in optimum amount over an entire field. Okay, so this is a very you can say unique thing about this PI, precision irrigation. The second thing is, this is the new generation of innovative system to monitor and control soil moisture deficiency and irrigation. In this irrigation system, generally we are observing two things. First one is moisture content of soil, and second one is water. If the moisture content of field is near to wilting point, or is simply you can say if the moisture content is reduces, we have a specific types of you can say sensors. Then they sense it, they transfer the signals to the system, and then the water would be supplied to this field. So this is the beauty of this precision irrigation system. Then question is arise, why PI? There are two forces for driving forces. Number one is excessive water application could contribute to surface water runoff or leaching of nutrients and chemicals to groundwater. It means if we are not using this PI, or other words, you can say if we are using other methods of irrigation, then we are applying, generally we are applying excess water in our field, and we are also applying different types of agrochemicals and fertilizers. The excess water is leaching down in the soil surfaces and go to this groundwater, and this can also be rain out to the rivers, or you can say water bodies, and after that we directly or indirectly consume this water again. So it means this is directly harmful to our ourselves also, and especially we can say this is directly harmful to our environment especially. Okay, so the precision irrigation system would have the ability to apply water directly where it is needed, therefore saving water and preventing excessive water runoff and leaching may be reduced. Okay, so this is the driving force. Okay, then internal regions, there are other two internal regions. The number one is very few fields are uniform in our country. If we are thinking generally if we are looking around you, then I think only Punjab and Haryana state, no one other state has, you can say, uniform fields. Okay, so the need for irrigation may differ between different zones of a particular field. Means the field is not, you can say, a plain. Simply actually I am just an agriculture engineer, so generally we are using this you can say labeler or different types of machines to label the laser labelers. Sorry, laser land labelers. We are not using the laser land labelers, and when we are not using this laser land labelers, it means our fields are not uniform in label. So there is a chance if we are applying the water, then the water may be stagnant at that place where the low line, and there may be some patches of land where the water may not be arrived because that area may be applied. So that's why most currently used irrigation system apply water at constant rate. Therefore, some area of a field may receive too much water, as I told you, and other area of a field may not receive required water. So this is also a very important point. That's why we should use this PI. Now, there is an important thing in precision irrigation that is known as scheduling. Scheduling means what? Generally, we are make our schedule for your examination schedule. If we are in a study, then we generally using examination schedule. Okay? And if we are your mother and your other ladies of your home, they are doing their activities with their different types of scheduling. Okay, so same things is happening for this irrigation purpose. And if we are using this scheduling in our irrigation, then this is known as irrigation scheduling. Okay, so irrigation scheduling is the heart of precision irrigation. Why? Because which simply knows where, when to irrigate, and how much irrigation water to apply. I will discuss in very clear words in my coming slides. Okay? An effective irrigation schedule helps to minimize profit while minimizing water and energy use. It means if we are using scheduling in precision irrigation, then the situation may be directly inverse, or you can say opposite. What happening in our traditional irrigation methods at that time, when we are using that irrigation system, there are two conditions. The irrigation expenditure or irrigation cost, in or other words, or you can say the major words you can use, input of irrigation is high and the profit is less. And if we are using precision irrigation scheduling, then there is a different thing. Here the input cost is low and profit is high. Okay. So now you can easily understand we are generally using over exploitation of underground water resources has resulted in alarming fall in depth of water table in the well command areas, as I told you. And there is an immediate need for selection of appropriate irrigation method to improve water use efficiency. Okay. So I am sure you all are agree with my these 2 points. And the answer of these 2 points is precision irrigation. Precision irrigation means micro and sprinklers, means MI and other irrigation systems is the best option. Why? Generally, if we are using this precision irrigation, it means we are going to use with the foundation of judicious use of water for our irrigation purpose. Okay. So now comparative efficiency of available methods of irrigation. What is happening still till now? If we are using surface irrigation method, then the irrigation efficiency is only 30 to 45%. And if we are using a sprinkler, then the irrigation efficiency of that field is 60 to 70%. And if we are using drip irrigation, it means the irrigation efficiency of that particular field may be as much high as 18 to 90%. So with these 3 lines, you can easily understand which type of irrigation method you have to use for your fields. It means you should use drip irrigation or sprinkler irrigation, because these 2 methods has highest irrigation efficiency of their field. No, precision agriculture. Okay. So because this is the training program of precision agriculture, so I am not going in depth with in this precision agriculture, but I am discussing only two things. In precision agriculture, there are chances to different types of patches found in your field, because I think you can easily understand the picture, my words with this picture. This is a field, and in this field, if you are seeing without, you can say, these sensors, then we look as a plain field. But if we are using this moisture stress, moisture sensors, then we found there are different types zones. The blue, this is the you can say highly moist area. The red, this is the less moist area, you can say dry area. There are green area, yellow area. It means there are different types of moisture content is available, soil moisture in your field. So if you can identify that area, it means you are using precision agriculture. Okay. So if we are using precision agriculture, then we have to utilize this precision irrigation, because precision irrigation is a part of precision agriculture. Okay. If we are supplying different types, if we are supplying water to our field, and there when the water is stagnant or high moisture content in your area, in your field, then that area may be highly compact. So experiments have done in Pantnagar to show the effect of soil compactness on crop response. It means there are 3 tubes, and you can easily understand, and you can easily see the low compact, the penetration of the roots is very depth. In medium, this is a medium, and in the high compact soil, then the penetration of you can say these roots are very less in depth. It means if we are not using right manner of irrigation, that our crops could not be succeed successfully. In this picture, you can easily see this area. This is high compact area, high soil compactness, and the plants there are well developed. It means there is a low compact area. It means there are patches like this in your field. So this is very you can say not good method for our agriculture practices. And if we are not using good irrigation practice, means optimum irrigation, then it is such type of situations occurring in your fields. Okay. So precision agriculture may use to improve a field or a farm management from several perspectives. Okay. There are few points to improvement of field or farm management. If we are thinking about engineering perspectives, then better irrigation means precision irrigation and tillage management. If we are using precision agriculture, it means you have to introduce special, or you can say specific type of tillage management in your field, and you have to opt better irrigation practices. It means you should use this precision irrigation. Okay. Then there are agronomical perspectives, technical perspectives, environmental perspectives, and economical perspectives. I am not going through because I have limited time to complete my talk. Okay. So this is a complete picture. You can say you can understand precision farming or precision agriculture concept. It means in precision agriculture, we are using you can say different types of sensors, or you can say advanced technologies employed to successfully cultivation of any crop in a particular field with the advanced technologies. In simple words, precision farming means the right input, the right amount, the right time, the right place, and one thing is not given in this picture, with the right manner. If these all rights you are using, it means it means you are doing a precision farming. Okay, so there are different things. I am not going in depth. Those are written in this slides. Remote sensing, GIS system, automatic yield recording system, automatic soil sensor, variable rate technology, advanced agronomy, advanced farm management, so on. Many things are utilized in this precision farming. At present time, drone technology is also introduced in our Indian agriculture system, and it is also directly related to precision agriculture. Okay. The overview of precision farming is first one is GIS. GIS is very important, global information system, and this all types of information is collected with the use of different types of sensors and receivers. Generally, we are using this computers, different types of computers using for this precision farming. And variable rate irrigation, if we are talking about precision farming, precision agriculture, it means we have to use this precision irrigation. Okay. Now the question again comes, why precision irrigation? As I told you, right time, right amount, right place. It means the precision irrigation system irrigates the root. Just, kindly, I may like your attention, please. Precision irrigation system irrigate the roots, not the soil. With this picture, you can easily understand. This is the root zone, and the water is supplied to the roots only, not the soil. Okay. Yeah. So there are a few, you can say, prerequisites for precision irrigation in agriculture. Whether we are using in our Indian agriculture or we are using in other countries, there are few prerequisites, prerequisites for precision agriculture. Number one is groundwater monitoring sensor. Second is irrigation water quality sensors, water conveyance monitoring sensors, and canal maintenance sensors. So these are prerequisite, you can say, things. I will be discussing one by one. The first one is groundwater monitoring sensors. Means we have few data regarding real-time monitoring of groundwater fluctuations. If we know the actual real-time data of the groundwater availability, then we have to plan or schedule our irrigation with this groundwater. Then remote sensing based system. So there are two pictures. Those are directly show each other. First one is show the real-time monitoring of groundwater fluctuations, and the second one is remote sensing based system. So this is the basic requirement of PI. Second one is irrigation water quality sensors. Why we should have this type of quality sensors? Because there are different types of chemicals and activity and properties found or having that irrigation water. If we don't have such parameters as per our crop requirement, then that irrigation may be harmful for the whole field. Okay. So there, the irrigation water quality sensors is used for measure pH, electrical conductivity, turbidity, sodium absorption ratio, boron, anions, cations, and other things. And water conveyance monitoring sensors. We also, if we are using this precision irrigation, then we have to have water conveyance monitoring sensors. Because if we don't have such type of sensors, then we cannot prepare our irrigation scheduling. Then if we are not using irrigation scheduling, as I told you, the irrigation scheduling is the heart of this precision irrigation, so then our total precision irrigation system may be failure. So that's why we have to have water conveyance monitoring sensors for our PI. Then irrigation water management sensors. There are different types of sensors that will utilize for our this PI. The first one is soil based, soil moisture, soil based sensor. Those are applicable for the measurement of soil moisture, like soil water content based soil moisture sensor. Then tension based. Second one is plant based. For plant based, thermocouples, yeah, temperature meter, or you can say water potential gradient, plant wilting system based. So these are different types of sensors. Those are used for plant based. And next one is weather based, humidity and VPD system. So these sensors are very important for this PI. Now, types of sensors. The first one is these 4 or 5 types of these are the, you can say, important sensor. Those are using in our PI. Other than these sensors, other or many other sensors are also useful for as per their area, their requirement, their you can say locality. So these are based on this type. Now, continuous accurate soil moisture measurement. I am just giving you the glimpse of you can say how this PI these sensors are used in our precision irrigation. So these taking the data every 15 minutes and transmitted every 30 minutes to the your system. Up to 3 sensors can be connected to each transmitter. Okay, so generally you can say capacitance technology, then neta sense and tensiometer. So as here you can see up to 3 sensors can be connected. If when you are connected 3 sensors, then it will be continuous, accurate and soil moisture measurement you can do easily. So this is a IRRI-wise TM. This is a trademark. IRRI, International Rice Research Institute, is using such type of technology for PI at here at Varanasi. There is a center, ISAR, International Rice Research Institute, South Asia Center, Varanasi. So that center is using this IRRI-wise technology for this precision irrigation system in their this paddy crop. Okay, if so, this is the few pictures. Precise irrigation techniques significantly increases the crop yield along with significant resource saving. So if we are using this precision irrigation, then these are pictures from Pantnagar. All 3 pictures are from Pantnagar. Okay. Then advantages: if we are using this PI, then it offers significant potential for saving water, energy and money. So this is the clear thing now you can get. If you are using this precision irrigation, it means you are saving water, you are saving energy and you are saving money. Then further, PI has the potential to increase crop yield. As I told you 3 or 4 times earlier, means if you are saving the water, then your input cost is reduced, and when you apply the water judiciously and the right time, right place, right manner, it means you definitely increase your yield. Then your profit will be increased. So there is an additional positive environmental impact from PI in that farm runoff. As I told you, the agrochemicals otherwise either leach down or run off to the water bodies. It means they may be harmful for our environment and our population or animals, and for each every life you can say those are available on this earth. Now, precision irrigation, again I am going to clarify what is the PI again. PI means right amount at the right time at the right place in right manner. Now, what is the right amount of irrigation? Means how much, kitna pani aapko dena hai, how much, what quantity you have to apply in your field. Then right time of irrigation, when you have to irrigate your field. Then right place of irrigation, where you have to irrigate your plant, root zone, whole field, it means, okay. Then right manner of irrigation means how, which method you will be utilizing to irrigate your field. So this is the crux of, you can say, PI. Right time, right amount, right place, and right manner or right method. Okay? Now, right time of irrigation, when to irrigate. Okay? With this picture, you can easily understand. This orange line is showing the irrigation given with the help of surface irrigation. Okay, it means this is the saturation area, and this is the wilting point. Okay, this is the field capacity. If this is the water holding capacity, this is showing this water holding capacity of the field. If you are using this surface irrigation, it means you are giving a irrigation 0 days after again you have to irrigate after 12 days, and after 12 days you have to irrigate. So what happening, the field is saturated and you again irrigate your field when the water holding capacity of your field is 50%. Okay, so the water is not utilized by the plants, but it goes useless. Okay, and now the second one is green lines. These are showing the irrigation with sprinkler. Okay, it means you have to irrigate your field after 4 days interval. This is the first irrigation, then the second irrigation, fourth irrigation, fifth irrigation, so on. Okay, it means this sprinkler irrigation is not so much, you can say, quite good as per the precision irrigation system. Okay. And the last one is the white lines. It means this is the your drip irrigation system. Okay. It means your when your plant require the water and you supply the water in that root zone, it means there are number of irrigation is many more, and the water loss is very less because you are not supplying the water to the soil, just you are supplying the water to the root zone. It means moisture status, you can easily see this drip versus other irrigation system. Okay, and here you can kindly understand what I am saying. This is soil water availability to plant concept. You can easily understand what is the soil water availability to the plant concept. So there is a line, this is known as a critical state line. Okay, and available soil moisture is 0.33 to 15 bars. If your available soil moisture is 0.33 to 15 bar, it means your plant can take, you can say, take the water when the field capacity is 0.33 bar. This is if the saturation condition, it means the field capacity at 0 bar, it means the plant cannot take the water, and in other conditions the plant here the wilting point means 15 bars, the plant here water is not available, it means dry situation. Here the saturation situation, and as the bar field capacity is increased, the wilting point, the water uptake of the plant reduces as per the subsequent manner. It means this is the critical situation. You can say this is the correct situation at which the plants consume, or you can say uptake the water from the soil. So soil can kept at field capacity with low flow drippers. It means if you are using drippers with low flow, then for higher water and fertilizer use efficiency. Higher water and fertilizer means if we are using this fertigation system with this drippers, then this is a very good condition for this uptake of nutrient as well as water for this plant. Okay. Next one is right place of irrigation, where to irrigate. Okay. So with this picture, I think this is there is no to elaborate. There are three irrigation methods: surface irrigation, sprinkler irrigation, and drip irrigation. In this portion means surface irrigation, if you are using this supply the water to your plant with this method, it means you flooded your field with the water, and the only this area use this water, means root zone is utilize the water, and other rest water is going to the west. And if you are using sprinkler, it means here definitely we are using less amount of water, but this area need not irrigate. So that's why in this drip irrigation system, only root zone is irrigating with the water. That's why this is known as right place of irrigation, where you have to place your irrigation water to your plant. Means only you have to irrigate your root zone, not other place. So this is, you can easily see, this is the drip irrigation system, and here the roots, and this is known as root zone, and you only supply the water for this place only. Okay, so this is the clear picture of this potato of Farrukhabad area. Now healthy and wet canopy of your potato. This is from Pantnagar and Farrukhabad, that potato belt. Okay, so this is also drip irrigation, dripper used in lychee crop, lychee plantation, lychee orchard, you can say. This is the bubbler. This is also used in our lychee crop. Okay, this is a have a good bearing of lychee in the this plant, this tree, you can say. Okay, now right manner of irrigation. Right manner means which method you are using to irrigate your crop. There are, as I told you, surface method is not good. Sprinkler irrigation is overhead system, and this is, you can say, 50-50. Okay, micro sprinkler irrigation, disc source, bubbler, pop-up, drip, and different types of online, inline, surface, and subsurface. Different types of drippers are used. So from my starting to at this point, now you can easily understand which type of irrigation system is useful for our plants with respect to reduce the utilization of water. It means this is the drip irrigation system. Okay, now there are different types of irrigation. Pressurized irrigation systems are available, that is known as sprinkler irrigation. Generally these are utilized 300 to 45,000 liters per hour. Now at present time, micro irrigation system, MIS, is also utilized. These are divided into two types: mini sprinkler or micro jet. These are utilized for 35 to 250 liters per hour, and drip, whatever I am talking about earlier. So this drip irrigation system is also known as trickle irrigation, boond tapak sinchao vidhi. So in this picture, you can easily understand drip irrigation is utilized only 2 to 24 liters per hour, and sprinkler irrigation is utilized 300 to 45,000 liters per hour. Okay. Now different types of MIS system are utilized in this irrigation precision irrigation system. Number one is surface, second one is subsurface drip irrigation system. There are different types of online, inline, microjet, micro sprinkler are using in this irrigation system. Now I going very fast because it's 9:39. Okay. There are different types of attributes available. These are controlled application, high soil water potential and root zone, partial soil wetting, maintain dry foliage, use of low quantity water, energy efficient fertigation, chemication can also done with this system, adoption of marginal water, adoption of landscape irrigation, adoption of protected crops. So these are different types of attributes. Those are, you can say, advantage if we are using this MIS system. Okay, so these are also different types of advantages. Okay, then there are some limitations I'm not going through. And this is the typical layout of a sprinkler irrigation system used in our India. Okay, generally, if you are interested to install this irrigation system, then simply you have to prepare a project with the NABARD or any other agency. At present time, generally, irrigation companies, engineers are, if you are contact and for any irrigation company, generally Jan, Netafem, Rongta, Premier, there are a number of companies are available in our India. Those are doing very good job to install this MI or this sprinkler and drip irrigation system. Okay, so there are different types of agricultural sprinkler systems. There are a number I am not going through because I think I have very less time. Okay, I will provide my PPT to the organizer, so the participants kindly go through with this slides. And if you have any query, then at last I am trying to give your answers. If at this time I cannot consider a question, then I will also provide my email ID and my phone number. Kindly you can call me or you can write me, then I will try to solve your question or problem. Then there are, when we are talking about the globally regarding PI, then countries having more than 50% area under a sprinkler and micro irrigation system. Generally, we are thinking the US is a very, you can say, #1 country with the technology, with the economy power. So that's USA. So USA is using 19 to 100% this MI irrigation system, but not, you can say, this USA, Spain and Italy comes under 50 to 60% of irrigated area, and 90 to 100% the countries are Austria, Czech Republic, Finland, France, Germany, Great Britain, Israel. Okay, so this sprinkler and drip irrigation system is invented in Israel because they have only a single river and they are doing their whole agriculture with the help of that water available from this that river with these sprinkler and micro irrigation or drip irrigation system. Okay, and 60 to 70% Macedonia, Zimbabwe, Hungary, Jordan, Cyprus. These three ABC category, you cannot found our India in this category. Because why? Because we are not bothered about this situation. We think we have, as I told you, my earlier slides, do we have enough water? So really we are thinking we have enough water. So that's why our country is not appearing in this list. It means our country is below this 50% of irrigated area. So the countries, those are comes in 90 to 100%. They are using central pivot sprinkler system. This is means for this system generally we need a big field, big farm to operate this type of irrigation system. Okay, so classification of agricultural sprinkler. Generally, these sprinklers type are based on operating pressure, flow rate, and wetted diameter. Okay, so there are three types: low, medium, and high. And flow rate is also 300 to 1,500 liter per hour, and the highest flow rate is 5,000 to 50,000 liter per hour. So these comes under rain gun category. Okay, then better diameter. Better diameter means how much area is covered with this sprinkler or rain gun. Okay, so different types of sprinklers are available. These are impact sprinklers. Okay, then this is the big gun sprinkler. Generally, these are using in you can say this golf court. Okay, golf court. Your landscaping, different types of hotels. So at that places, these big sprinklers. This is known as rain gun. Okay, the working view of rain gun. So such type of view you can find if the rain gun is operating condition. Pop-up system for landscape and irrigation. This is the pop-up system, generally landscaping and this what I am saying. Golf court areas, to irrigate the golf court areas, grass of that golf court area. Only these are using. Now, medium and high discharge impact sprinkler. So as I told you, there are different three category: low, medium, and high. So these are the low, medium, and high discharge impact sprinklers. Okay. So under tree sprinkler system, there are few pictures I am also showing you. These pictures are from Pantnagar. Okay. Then self-propelled center-powered sprinkler system. Self-propelled center-powered sprinkler system means this is a center and this rotate to this field with the help of these wheels. Those are fixed with this sprinkler system. Then it covers such area. Okay. Yeah. Aerial view of center power system. This type of irrigation system are used at that those countries. Those are having 90 to 100% irrigation with this you can say MI system. Then micro irrigation, as I told you, micro sprinkler, bubbler, drip irrigation, jet, etc. So this is the drip irrigation system. This is the similar of sprinkler irrigation system, but at that generally sprinklers are used, and in this system generally the poly pipes are used with the different types of drippers and with different capacity. Okay. Then advantages of micro irrigation. Generally it saves money, labor, and water. Okay. Then various types of MIS, micro irrigation system, then surface drip irrigation system, then bubbler, then subsurface drip irrigation system. As I shown you to potato field, and this is the protected cultivation system. Then micro sprinkler. Generally, micro sprinkler is used to irrigate the upper surface of the soil. Okay. Then wetted front. Yeah. Wetted front means if a dripper is placed here, and how much area, you can say how much dia that cover, that is known as wetted diameter. So there are only, if a single dripper is used, and there the wetted diameter will depends on the type of soil. If it is used in sandy soil, it means this penetrate, or you can say infiltrate in the depth, and the wetted diameter may be 0.3 meter. And if it is used the same dripper in loam soil, then the wetting front and wetted diameter will be 1 meter. Okay. And if it is utilized in heavy clay, it goes up, the wetted diameter goes up to 1.5 meter. Okay. So this is the wetted diameter, this is the wetted front. Okay. Now, water distribution and dripper system. Okay. If we are using low discharge drippers, it means low discharge drippers should be used, or you can say low discharge drippers are designed for shallow depth root plants. Okay. And high discharge drippers are designed for deep root depth plant. Okay. Clear? Now different types of drippers available online, inline, Okay, bubbler type, micro and mini sprinklers, micro sprinkler irrigation, as you've seen many times, many places, many fields. Okay. So this is the subsurface and drip irrigation system in potato crop. With this picture, you can easily understand. Okay. So this is the potato crop. Okay, and the irrigation pipe is in this furrows. Okay, and this irrigate the whole field. You can see, and this is the single row. You can say, and this is the double bed, double seeded bed. Okay. This is the transplanting of onion under pressurized drip irrigation system. This is the picture from Pantanagar. This is excellent onion crop under pressurized drip irrigation system. Okay. This is the cabbage crop under pressurized drip irrigation system. How beautiful is looking. This is the cucumber crop in low tunnel. This is also your cucumber crop, okay, in protected cultivation polyhouse. This is cherry tomato under drip irrigation system under polyhouse protected cultivation. Then precision irrigation drip tap used for capsicum in protected cultivation. So from these all experiments, the yield can be achieved as high as 25 kg per square meter for this capsicum, and high quality produce average fruit size here where 200 gram of this capsicum. Okay, this is also capsicum. Okay, so if we are using this drip irrigation, then there are number of benefits are associated with this. I am just telling you the what you get. You can increase your income, you can increase your quality, you can supply the water with a uniformity manner. Okay, and what will be decreased? Water quantity is definitely will decrease, energy requirement will decrease, labor requirement will decrease, fertilizer and pesticide requirement will also be decreased if we are using this drip irrigation system. Okay, now another thing that is known as fertigation. Fertigation means if you are using this precision irrigation system, then you can apply that nutrient with this irrigation system. So traditionally what we were doing, our farmers were doing such types we are using irrigation, and such this method means broadcasting method is used for applying the fertilizer. Now fertigation versus fertilizer, application of nutrients. Then conventional pre-plant fertilizers, generally we are using such type. Okay, plants get a larger doses of fertilizer than they require at the time it is applied, losses occur. Okay, and if we are using fertigation, then fertilizers are applied according the need for nutrient following the uptake rate of the crop. So this is the clear-cut difference between fertigation and fertilization. Okay, this is fertilization and this is fertigation. So why fertigation? In broadcast or band application, 40% of fertilizer fall beyond the active root zone. Okay, and active root zone area due to restricted wetted area. Okay. So this is the, if we are using this broadcast system, then the 40% of your fertilizer can go out or go waste, because if that is not placed with the root zone, it means there is no use of for plant. Then threats of applied nutrients, it means plant removal, volatilization, immobilization, lattice chemical fixation, leaching, and soil erosion and runoff if we are using direct applied of nutrients. Okay, then ways to improve efficiency. Selection of crop variety, which type of variety you are using, method of application, time of application, which type, when you have to apply, then nutrient source, what is the source of your nutrient, then land and irrigation management. Okay, then use of inhibitor modified forms and integrated use, then balanced nutrition. If we are using to be a good fertigator, a grower first need to a good irrigator. Clark GA 1991 he's coined. It means if you are interesting to apply your fertilizer or your nutrient with the water, it means you have to good quality irrigation system. Okay. Then water saving technologies for increasing water use efficiency. This is the simple words you can understand. Water saving technologies for increasing water use efficiency. If you increase the water use efficiency, it means you are already saving the water. To you can say conceptualize these lines, there are two more lines. For that, drip irrigation and drip fertigation. If we want to save our water, if we want to save our energy, if we want to save our money, then we should use drip irrigation, and we should use fertigation with this drip irrigation system. Okay. So what is the benefit, or how nutrient distribution pattern found in the drip irrigation system? If we are utilize this surface irrigation, then more amount of this fertilizer going waste with the leaching. Okay. And if we are utilize drip, then it will available in the localized system. Okay. And drip fertigation we utilize, it means they distribute the nutrient in the uniform manner in our field, or you can say root zone. Okay. Then fertilizer use efficiency, and near about 95% applied fertilizer taken by the plants if this drip fertigation system is utilized. There is a report, nitrogen, phosphorus, and potash supply fertilizer use efficiency for a particular field. It means soil application 30 to 50%, and drip it will 65%. If it is utilized with drip fertigation, it means 95% nitrogen, 45% phosphorus, and 80% potash will be taken by the plants. Now, micro irrigation and fertigation scheduling in lychee. These all pictures are from Pantnagar. Okay. So this is the drip fertigation system is using in lychee. I have only 3 minutes, so going fast. Heavy fruiting of lychee under bubbler irrigation fertigation system. View of MIS, you can easily see 5 months old healthy banana garden in a drip irrigation. Generally here in our Banaras and Mirzapur district, many farmers are growing this banana crop. So this is picture from that place. Okay. So field crops under MI fertigation. This is the maize crop. This is the production of that maize crop. This is a high quality crops of seed crop, a sweet corn. Then sugarcane under drip fertigation. If conventional system is used, then the yield is 25 to 350 quintal per acre. And if drip fertigation system is applied, then this is near about double, 60 to 65 quintal per hectare. This is the benefit. Excellent cabbage crop under the low pressure drip fertigation. This is the from Pantnagar research station. Now, automation in micro irrigation system. So basically, time-based, volume-based, and real-time feedback systems are useful, very important. As I told you earlier, the prerequisite system, there are 4 things I have earlier told you, and 3 are giving here. First one is moisture sensor, then hydraulic valve, and generally this is using, and controller and control head of micro irrigation system. Generally, it's this such type of computer software is used, and such type of pumping and pipelines and machineries are utilized, and this is the fertigation unit. Just this is a trial version. Okay. Fertigation control unit in a large area when it is applied in a large field. Okay. Then this is automation on MI system. So this is fully automatic system. This is comes under the precision irrigation system. Okay. Then automation in MI irrigation for large farm. So there you can easily see there are when this PI is utilized in a large farm, there is a number of pumps are utilized. There are a operator that will control this all operation of this field, and this wireless control system under automation is applicable for this AI system. Okay, it is already 8. I am just only taking 5 minutes more. So this is wireless control system. You can easily understand from this. This is the field. You can say this is our plants or tree. So here is a soil probe. This connected to this system, and this is EIT elementary electric impedance tomography. So the soil probe give the data, means the soil moisture is less, or you can say soil moisture is reduced. Then the signal going reflects to the goes to the this computer sensor. Here is a receiver. This receive the data, means, and this operate this irrigation system. Then automatically the water is applied to the field and irrigate the crop. So this is a simple technique that is used. The simple this is also automation in MI, irrigation, fertigation, and microenvironment control in greenhouse. That is for open house, and this is for greenhouse. Okay, so this is from my side. At the end, this is the conclusion. I am just want to tell you, we need to utilize water resources more judiciously to address the problem of scarcity and quantity in the backdrop of climate change. Day by day, our population is increasing. The populations of whole world is increasing, and the availability of water is day by day, or you can say fraction of second, fraction of time, it is decreasing. So the situation is really the situation is very going to very bad condition, and we are not really thinking about the availability of water. So for irrigation purpose, if we are need to produce we will be the world population near about 250, maybe 9 billions. For to fulfill the demand of food, we should use different types of agricultural technology. So this precision agriculture is also important for that purpose. And to fulfill the requirement of precision agriculture, this precision agriculture irrigation is also equally important to fulfill the food demand of this regular increasing population demand. So thank you so much. This is from my side. If you have any query, any question, kindly, I am available here. Please.
Thank you so much. Thank you for making us understand the basics behind precision irrigation and the key principles involved behind the same. Thank you for elaborating on the technologies and methods precision irrigation, and most the benefits like water conservation, improved crop quality, reduced energy cost, and environmental sustainability. We understood how important is precision agriculture in scenario of climate change. Thank you so much for such detailed talk. We would like to hear from you soon more about it. Thank you so much once again.
So thank you so much, ma'am, and I am thankful again, Dr. Ankur Sharma ji, to provide me this opportunity. I am not interact with my audiences. I am just giving my thoughts to audience. As I told you, I will provide my PPT to you, and there.
डॉक्टर साहब एक निवेदन है आपसे, डॉक्टर साहब.
Yes.
मैं चैट बॉक्स में, आप चैट बॉक्स में अपना ईमेल लिख दीजिए. यदि किसी को कोई क्वेरी होगी वो डायरेक्ट ईमेल कर से आपसे पूछ लेंगे. बाकी मैं आपका ये रिकॉर्डेड वीडियो सारे पार्टिसिपेंट्स को दूंगा. यदि आप अनुमति देंगे तो मैं पीपीटी भी शेयर कर दूंगा.
बिल्कुल सर, you can share my PPT, because as a professor of BHU, professor in BHU, we are thinking on a simple line. everything which is available with me, this is not only for me, this is all over, all the participants, for all the students, whosoever is required, that material is only for that persons or gentry also. So I am trying to write my email. Okay.
ईमेल आप चैट बॉक्स में लिख दीजिए प्लीज.
I am just searching the chat box. Where is the chat box?
So there'll be a message kind of sign, a symbol in your screen. Hello.
Yeah, ma'am.
So did you get it? Or you can
yeah,
spell it out, sir. So you can spell it out.
Okay. My email ID is okay, 1 minute. This is my first slide. I am
Yes,
writing.
sir. Yes, sir.
You know, this one. Yeah. skgoyal@bhu.ac.in.
हाँ, ये बहुत बढ़िया हो गया सर, ये बहुत बढ़िया. इसका
Yes, sir.
स्क्रीनशॉट
Yes, sir. Everyone can take a
लिया जा सकता है. बहुत
screenshot.
बढ़िया.
Yes.
My phone number and WhatsApp
And
number
if you
are
have
also
any
available.
questions, अगर
जी.
हमारे participants के पास कोई और भी questions हैं, so they can directly ask Goyal sir, or they can write to us also. They can contact us with their questions too. Right, Ankur sir?
हाँ हाँ बिल्कुल ठीक है. जी जी.
दोनों से आप पूछ सकते हैं, हम आपका contact Goyal sir से करवा देंगे.
Yes, definitely. So thank you again.
ठीक है, बहुत बहुत धन्यवाद गोयल साहब, आपने अपना बेशकीमती समय दिया.
Thank you so much.
Thank you.
Thank you, sir. धन्यवाद. Good night, everyone.
Good night.
गुड नाइट. रोहित जी कंक्लूड करिए आप.